Have you ever found yourself chatting with an AI late at night and had a little thought flicker in your brain? Is this secretly boiling the planet? Well, today, that's exactly what we're digging into. We're going to look at the real environmental footprint of AI, from the massive data centers down to your single individual prompts and even its surprising thirst for water. Let's get right into it. So let's just start with the most basic question, right? We're all using these tools every day. What is the actual carbon cost of just asking an AI a single question? Is it a lot? Is it a little? How do we even begin to wrap our heads around that? Well, let's try to put it in perspective. Think about something you do every day, like brewing a cup of coffee. That has a small, but definitely measurable carbon footprint. So how does one query to a big AI model stack up against that? Is it more? Is it less? Honestly, the answer might surprise you. Okay, so first up, let's zoom all the way in and look at the impact of just one prompt, your personal one-on-one interaction with an AI. It turns out the number is incredibly small. We're talking about 0.13 grams of CO2 for a single prompt on an average US power grid. And to really put that in perspective, that is 1/50th the mass of a single grain of rice. It's practically nothing. So case closed, right? AI is green, let's all go home. Well, not quite. It turns out that focusing on that one tiny prompt is like trying to understand a flood by looking at a single drop of water. We're asking the wrong question. Because the real story, the one that actually matters for the climate, has nothing to do with your one little question. It has everything to do with the staggering, explosive scale of the entire AI ecosystem. And this chart, wow, it really says it all. The International Energy Agency is projecting that the electricity that data centers gobble up could more than double by 2030. And a huge driver of that growth, you guessed it, AI. We're not talking about grains of rice anymore. This is a massive new demand on our global power supply. And look, this isn't some abstract problem for the future. It's happening right now. In a place like Virginia, which is a hot spot for data centers, they already use over a quarter of the entire state's electricity. In Dublin, Ireland, it's even more. This growth is putting very real stress on our power grids today. But okay, it's not all doom and gloom. This is a super nuanced picture. Because while the demand for AI is exploding, the technology itself is getting way smarter and more efficient. Just look at the energy it takes to train these things. It has absolutely plummeted. Compared to older models from the GPT-3 era, some of these newer designs can use around 3 times less energy. And if you run them on a cleaner power grid, they can produce up to 14 times less CO2. That's a huge leap in efficiency. And that's because at the end of the day, your single prompt matters way less than these big variables. Things like, how clean is the power grid where the AI is running? How efficient is the building itself? What kind of chips are they using? How cleverly is the software designed? These are the things that cause massive swings in the real footprint. And beyond carbon, there's this other hidden cost we have to talk about, water. Now, you may have heard these viral claims that a single prompt uses up a whole bottle of water. That's a huge exaggeration. The reality is more like a few milliliters per question, mostly for cooling the computers. But still, when you multiply that by billions of prompts, it really starts to add up, especially in places that are already struggling with water shortages. So we've got this fascinating race going on, right? On one side, AI demand is just exploding. On the other, the tech is getting way more efficient. So which one's going to win? Well, there's a catch. It's a classic economic idea. Some people call it the Jevons paradox. As AI gets more efficient, it also gets cheaper and easier to use. And what happens then? Well, we use it more. A lot more. We put it in everything. And that explosive growth in use can actually cancel out all the savings from efficiency, and we could end up using even more energy overall. It's a classic rebound effect. So if our individual prompts are tiny and efficiency gains might get eaten up by growth, what actually moves the needle here? Let's look at the levers that have the biggest impact. For the big tech companies actually building these AI models, the path forward is pretty clear. It's all about location, putting your data centers where the power is green. It's about using the absolute best hardware and the smartest software designs. And it's also about things like clever low water cooling systems and scheduling the really big computing jobs to run when there's tons of wind or solar power available. And what about businesses that use AI? It's really about being smart. You don't need a giant energy-guzzling model to answer a simple question. It's about using smaller, more specialized models, saving and reusing answers so you don't ask the same thing twice, and choosing to run your operations in cloud regions that are powered by clean energy. It all makes a huge difference.
And finally, what about us, for you and me? Yeah, our individual footprint is small, but our collective habits really do matter. Just simple things like asking for a short answer when you don't need a whole essay or grouping a few questions into one conversation. That can collectively reduce the load on the system. So here's the bottom line. It's a story of two competing truths. On one hand, the impact of your single prompt is minuscule, almost zero. But on the other hand, the growth of the entire system is very real and very significant. AI is getting crazy efficient, but our appetite for using it could grow even faster. That's the core tension we have to manage. And that leaves us with the ultimate question, the one that really decides everything. The future of AI's environmental impact? It isn't really about AI. It's about a race. Can we clean up our electricity grids faster than our demand for artificial intelligence grows? The answer to that is what will determine AI's true climate legacy.